All right. On section 1.6, we're relating sine to cosine to tangent to cotangent and all those together. So, if we want to find the sine of A and we're given the cosine and we know we're in quadrant 2, how in the heck are we going to find the sine? Well, if we're told what quadrant it is, that is a good clue to draw a quadrant. Okay? So in quadrant 2, if I'm down here somewhere, you just draw a triangle down in quadrant 2. Do not ever draw over to the y-axis. You always draw up to the x-axis in trig. Quadrant 2. Yeah, like I said, in quadrant 2. Come on, Molly. Let's get it right. I'm kidding. Yeah, that was my mistake. Quadrant 2. Okay? Cosine is what over what? Adjacent over hypotenuse. The adjacent side is -8. The hypotenuse is 11. Why didn't I put the negative on the hypotenuse? Because the hypotenuse is never negative. It's always positive. The sides might be negative. The hypotenuse is always positive. Now, if I want the sine, I'm just missing this side of the triangle, right? And opposite over hypotenuse will give me the sine, so I have to do the Pythagorean theorem to figure out what that side is. So Pythagorean theorem, c squared equals a squared plus b squared. 11 squared equals -8 squared plus b squared. 121 equals 64 plus b squared. Subtract 64 from each side. I get 57. Then take the square root of 57. Is there a perfect square? Is there a perfect square that goes into 57? I know 3 goes in there, but it goes in there like 19 times. But I'm looking for perfect squares like 4, 9, 16, 25, 36, 49. None of those go into 57, right? No. So this side is just plain and simple the square root of 57. Is it positive or negative? Positive, because in quadrant 2, we're going up. So it's the square root of 57 over 11. That's how we solve that. We're given cosine. That's how we find sine. The next one, we're given sine. We're told the cosine is positive. In what quadrant would sine and cosine both be positive? In what quadrant would sine and cosine both be positive? 1. So I'm going to draw my triangle over here. Quadrant 1. The sine is 2/7. Here's my angle. Sine is opposite over hypotenuse. So we're just looking for cosine now. Okay. So again, the Pythagorean theorem. 7 squared equals 2 squared plus b squared. So 49 equals 4 plus b squared. If we subtract 4, b squared equals what? 45. So if we take the square root of 45, does that have any perfect squares that go into it? Sure does. 9 does. How many times? 5. So it's the square root of 9, square root of 5, which is 3 square root of 5. So this side of the triangle is 3 square root of 5. So the cosine is 3 square root of 5 over 7. Okay. Those are, you have to do a little work to figure them out. Have to do the Pythagorean theorem. Okay. Not just going to come up with those numbers out of your brain. Most of you are smart, but you're not quite that smart. Okay. So you got to do the Pythagorean theorem, figure out them. Okay. Now, you don't have to be quite as smart to do number 3. 285 degrees. Where's that angle? 285. A, B, C, or D? D. It is D. Because 270 is straight down, so not in quadrant 1, 2, 3, or it's in quadrant 4. The reference angle. A reference angle is how far the angle is from the nearest x-axis. One more time. A reference angle is how far an angle is from the nearest x-axis. We're going to be using reference angles a lot this year. So we need to know how to find a reference angle. So here, we got to figure out how far 285 is away from the nearest x-axis. Well, the nearest x-axis would have a value of 360 degrees. It would also have a value of 0, but 360 works a whole lot better here. Okay? Because what's 360 minus 285? 75. The reference angle is 75 degrees. Now I need to change that into radians. Well, from the first part of the chapter, to change degrees into radians, we multiply by pi and we divide by 180. Now, 5 goes into each. 5 goes into 75 15 times. 5 goes into 180 36 times, I think, right? And then 3 goes into each 5 times and 12 times. So it'd be 5 pi over 12. You trust me? 75 degrees is 5 pi over 12. Okay. All right. 4 pi over 3. Now, if you're going, I have no idea where 4 pi over 3 is. Well, 3 pi over 3 is pi, which is 180 degrees, right? So 4 pi over 3 should be past that somewhere. How far? Well, it's either A or B. Now, luckily, you have the unit circle that you have been given. 4 pi over 3 is on the unit circle. And if you look close enough, it looks more like A than B. So, how far is 4 pi over 3 away from here? Well, we just said 180 degrees is 3 pi over 3. Okay? So this is 3 pi over 3 right here. This is 4 pi over 3. How far apart is 4 pi over 3 away from 3 pi over 3? What's 4 pi over 3 minus 3 pi over 3? Pi over 3. Now, what is pi over 3 in degrees? Now, you could look at your unit circle and figure that out. Look at where pi over 3 is. How many degrees is associated with that? It is 60 degrees. We must be 60 degrees away from the x-axis here. Okay? 4 pi over 3. 60 degrees past the x-axis, 240 degrees. Is 4 pi over 3 the same as 240 degrees? Look at your unit circle. Is 4 pi over 3 the same as 240 degrees? Yeah. Okay, so all this should make sense. We're 60 degrees down from 180. We're at 4 pi over 3, which is pi over 3 away from the horizontal axis. Reference angles. How far are you away from the nearest x-axis? 705 degrees. Uh-oh. Is 705 degrees on your unit circle? No. So what you have to do is find a coterminal angle. Coterminal angles from the very first day of trig. Coterminal angles are how far apart? 360. So we have to subtract 360 from 705. What do we get? 345 degrees. Looking at your unit circle, where is your 345 degree angle, A, B, or C? B is your 345 degree angle from your unit circle. How far is 345 degrees away from your nearest x-axis? 15 degrees. What is 15 degree angle in radians? 15 times pi over 180. Well, 15 goes in perfectly into pi over 180 12 times. So it's pi over 12. Negative 5 pi over 6. Negative 5 pi over 6. Now we're going this way around. 5 pi over 6 is pretty close to 6 pi over 6. What's 6 pi over 6? How many pi is 6 pi over 6? 1. We're close to pi. Where is pi at? 180 degrees. So we're most of the way to 180 degrees. We're this far, basically, from 180 degrees. Okay? So, which one is it? Is it B or C? C, because we have to go in the right direction to get there. We have to go in the negative direction. So it is choice C. What's your reference angle? Well, I just said we're really close to 6 pi over 6. We're at 5 pi over 6. How far are we away? What's 6 pi over 6 minus 5 pi over 6? Pi over 6. What is pi over 6 in terms of degrees? 30 degrees. Okay? All right. It says use reference angles to figure out the following. What I say is you don't have to use reference angles. I mean, you can if you want, because 150 degrees is 30 degrees away. So cosine of 150 is the same as the cosine of 30. It's just in the second quadrant, so it's negative. But you have your unit circle to help you. So you don't have to worry about so much about reference angles. You can just look at your unit circle, see what the cosine of 150 degrees is. And the cosine of 150 degrees is in radians. Or not in radians, in radicals, negative square root of 3 over 2. I said radians, I meant to say radical form with radicals. 7 pi over 4. Again, that's on your unit circle. Where are we? Well, cosine is your x value, 7 pi over 4. What do we get? Square root of 2 over 2. Okay? So finding the exact values is pretty easy until we get to here. Negative 10 pi over 3. Is negative 10 pi over 3 on your unit circle? No. Positive 10 pi over 3. Is positive 10 pi over 3 on your unit circle? No. We got to use coterminal angles. So I want to use coterminal angles, not just to get it closer, but I want to go all the way positive. I want a positive number there, not a negative. Okay? Coterminal angles are 360 degrees apart, or how many radians apart? 2 pi radians. What over 3 is 2 pi? So we take negative 10 pi over 3 plus 6 pi over 3, and we get negative 4 pi over 3. Now, that would be close enough for me to figure it out, but I want a positive answer because my unit circle set up in positive numbers. So I'm going to add another 6 pi over 3 to it. Negative 4 pi over 3 plus 6 pi over 3 is 2 pi over 3. Now, can I find the sine of 2 pi over 3 using my unit circle? Yes, it's very easy. The sine of 2 pi over 3 using my unit circle is square root of 3 over 2. Let's do that with cosine of negative 7 pi over 3. Cosine of negative 7 pi over 3, so if I start at negative 7 pi over 3, and if I add 6 pi over 3, where am I at? Negative pi over 3. I don't like negatives, so I'm going to add another 6 pi over 3, and it gets me. So I'm looking for the cosine of 5 pi over 3. So using your unit circle, find the cosine of 5 pi over 3, and it is simply the number 1/2. Isn't that unit circle nice? We can help us find a lot of things. These make them coterminal angles for positive angles. Life is good. This problem you'll see on the test. I guarantee you that. So you're going to have to find the sine of pi over 6, the cosine of pi over 6, tangent of pi over 6. It might not be pi over 6 on the test. It might be 5 pi over 6, or it might be 2 pi over 3. Whatever it is, but you'll see a problem look just like this. So sine of pi over 6. Look on your circle. Sine of pi over 6 is 1/2. Cosine of pi over 6 is? Nobody usually has problems with those two. It's this where they start to fail. Okay? Tangent is sine over cosine. So tangent is 1/2 over square root of 3 over 2. This is a complex fraction. How can I simplify a complex fraction? Multiply both the top and bottom by 2. And we get 1 over square root of 3. Can we leave the square root of 3 on the bottom? No. So how do we get rid of the square root of 3 off the bottom? Multiply by square root of 3 on the top and bottom. So you get the square root of 3 over 3. Okay, cosecant is the reciprocal of sine. This one's easy. What's the reciprocal of 1/2? 2. Secant is the reciprocal of cosine. Not so easy. You have 2 over square root of 3. Cannot leave it like that. Because the square roots we don't leave in the denominator. So what do we do on the top and bottom? Multiply by square root of 3. So you get 2 square root of 3 over 3. That's the answer. Cotangent of pi over 6. Cotangent is the cosine over the sine. So it's the square root of 3 over 2 over 1/2. Again, if we multiply both top and bottom by 2, the top becomes square root of 3. What does the bottom become? 1. And square root of 3 over 1 reduces down to just plain simple square root of 3. So you'll have problems on your test with 6 blanks on them, and you got to figure out sine, cosine, tangent, cosecant, secant, cotangent for one of your main angles on the unit circle. Okay, so we'll have a couple of those. 330 degrees. Find 6 trigonometric functions. That's the same as the last problem that we just did. It's just in a different format. What's the sine of 330? Look on your unit circle. Sine of 330 is negative 1/2. Cosine of 330. Square root of 3 over 2. Tangent of 330. Ooh, we have to do the sine, negative 1/2, over the cosine, square root of 3 over 2. Get rid of your complex fraction by multiplying by 2. You got negative 1 over square root of 3. Can't leave square root of 3 on the bottom, so multiply top and bottom by square root of 3. So it's negative square root of 3 over 3. Cotangent. Well, we just flip this over. Square root of 3 over 2 over negative 1/2. So you multiply both sides, both top and bottom by 2. You get square root of 3 over negative 1, which is negative square root of 3, fully reduced. Don't write it over 1. It's just negative square root of 3. Secant. Secant's a reciprocal of which one? Sine or cosine? Cosine. It's a reciprocal of cosine. So if you flip over cosine, 2 over square root of 3, can't leave square root of 3 on the bottom. So it's 2 square root of 3 over 3. Cosecant is the reciprocal of sine, so it is negative 2. The reciprocal of negative 1/2 is negative 2. Okay? And the last ones on this assignment. Is the cosine of 300 the same as the negative cosine of 60? What's a cosine of 300? Positive 1/2. What's a cosine of 60? Positive 1/2. If we put a negative in front of it, it's negative 1/2, right? Are these two equal? No, that is a false. Now, how far is 161 away from 180? 19 degrees. So these have the same reference angle. These have the same reference angle. So 161 is here, 19 degrees away from the horizontal axis. 19 degrees is 19 degrees away from the horizontal axis. So they're going to have the same x value, except for what's the difference? This one will be negative. This one will be positive. That's what it says here. The cosine of 161 is equal to the opposite sign of the cosine of 19. True or false? Well, that is true. That is true. Because this is equal to the opposite of this. This is positive point whatever, whatever, whatever. So the opposite of that would be negative whatever, whatever, whatever. Okay? So same reference angle, because they're both 19 degrees away from the horizontal axis. They should be opposite signs if they're in quadrants 1 and 2. If cosines in quadrants 2 and 4, they should have the same sign. Here they were in 2 and 4. They should have the same sign. This said the opposite sign, so that's why it was false. These ones were in quadrants 1 and 2, so they should have opposite signs. It says opposite signs. That's true. This one, 3 pi over 14, 11 pi over 14. Oh my, I did it now. 3 pi over 14, 11 pi over 14. 3 pi over 14 is somewhere here. 11 pi over 14 is somewhere here. Now, this is 3 pi over 14 away from the x-axis. 11 pi over 14 is how far away from 14 pi over 14? 3 pi over 14. So they are the same reference angle. These are the same reference angle. What do we know about sine in quadrants 1 and 2? They are both positive. Sine in quadrants 1 and 2 are both positive. This says one's positive, one's negative. Is that true? No. This would be a false statement. This would be a false statement. Okay, so you'll have problems that look like that. 20 problems. This will take you a little bit to work on, but because I'm a nice guy, we're just going to do this. Like if I was mean, I would assign you this, and in 20 minutes we'd review for the test and do a sample test while you're gone, and then take the test on Thursday. But I'm not that mean. I'm a nice guy. So we're going to wait all the way until next Tuesday for the test because I'm such a nice guy. So there we go. Now, some of you didn't finish the last assignment. Make sure you get that done today because you will have time to work today.